Okay, guys, I'm just gonna basically tell you the answer for all the calculation questions. If you got it wrong, please let me know. Then we'll discuss the working on how to achieve that specific answer. But once again, some of these questions, the answer is not correct lah. Okay. But for most of these here, question one, two, three, all the way until nine, did anyone not get the answer given to you or not? And when I say anyone, I mean Hayden, since he was the only one that actually did it. Everything correct for question 1 to 9. Everything can do Okay, then I'm just going to move on from here. If you have no questions, I move on Okay, then from here, question number 1. What do you get for this one, Hayden?
I got B.
B, basically 50 times 10 minus 50 times 2 right? Which is correct. Then for number 2, what do you get?
B.
Kinetic energy changes. How come? And then momentum stays the same. Why?
C.
Uh, what do you change? Okay, the answer is C. How come?
Because the kinetic stays the same and momentum changes.
Care to elaborate a little bit more besides reading back the answer back to me? How come the momentum changes? How come the kinetic energy stays the same?
Because the momentum like bounce back. So like this, like when it hit the wall, it gets momentum and then it bounces back.
Not exactly. It's because momentum is a vector quantity. If let's say this one was positive 10 kg meters per second, right? This would have been negative 10 kg meters per second. That's why there is a change in momentum. But the kinetic energy stays the same. How come? Okay, maybe you guys have forgotten this. The kinetic energy formula, which we're going to talk about later, is basically half mv square. Right? If they have the same speed, and the mass is definitely not going to change, then it will have the same kinetic energy. You got what I mean?
Yeah.
Okay, and the last one, what do you get?
A.
Yeah, obviously impulse. Okay, guys, those that didn't do it, please just write down an answer and attempt it later on. Okay, moving on to this next question here. Hey, write your answers, guys, because there's like quite a bit to cover for the energy chapter. The first question, do you guys get 1,400 kg meters per second? And when I say you guys, I mainly mean Hayden because he's the only one who did it. Do you get this?
Yeah.
Second one, 1,400 as well.
Yeah, it's the same.
B, you said you couldn't do, right? Wait, B, you said you couldn't do, right?
Yeah.
Okay, so let's look at this question here. It basically says that in the crash test, the passenger compartment comes to rest in 0.2 seconds. This is your time. And they're asking you to find deceleration. First and foremost, what's the formula for deceleration again?
V minus U over T.
No, that's for acceleration. Deceleration will be the opposite, right? It should be,
T over V minus U.
no, U minus V over T, bro. Instead of final minus initial, it will be initial minus final. Okay. So right now, I need to know how much is the initial speed lah, right? Which they already said, this is your initial speed, right? 20, right? And then after that, how much is my final speed? My final speed is when it crashes into the wall, So my final velocity will be how much? When it crash into the wall already, what's my velocity?
0.2. 0.
0. And then your time will be 0.2, right?
Yeah.
And thus you're going to get a final answer of 100. What's the units for deceleration again?
Meters per second square.
Very good. You saved him. It's 100 meters per second square. It's the same units as acceleration. Okay. Then after that, for question C, do you manage to do? It's basically just your F equals to MA formula, this thing times this thing only. Then you'll
Yeah.
get 5600 newtons. And this last question here, which I want to highlight a little bit because students always get this one wrong. It says that the deceleration of the dummy is less than the deceleration of the passenger compartment. Explain why this is beneficial in terms of safety of the passenger. Guys, today if you think about it, right, since F equals to MA, pay attention here. All right, don't write down. Just pay attention here. Since F equals to MA, right, if I have a smaller deceleration or acceleration, how does that translate to my force? Will it be higher force or lower force? Jolie, will it be higher force or lower force if I have lower acceleration or deceleration?
Lower.
Good, it will be lower, and that is why it's beneficial, right? Today, and the dummy, which is most likely the human later on, right? If it has a less deceleration, it's basically going to have less force during impact, and thus it's going to have less damage to whoever is riding on it, lah. That's why you're going to say, less deceleration leads to less force acting on the dummy, which prevents him from major injuries. Major injuries. Something along the line, or doesn't crack his head or something. What? Okay, Ken? Good. Excellent. Right, something along the line side. It doesn't have to be word by word. Okay, all right. Can already know. Oh, wait, can already know. Good. Okay. Next, moving on to the next part here. Once again, check answer. This one is very straightforward lah. This one is very straightforward. Just do your calculation only. Do you get 1.2 here? Do you get 1.2 here? And then it must be kgs meters per second. Make sure you write your units. And do you get 800 newtons here or not? Anyone? Once again, when I say anyone, I mean Hayden. Do you manage to get this or not? Huh? Correct everything?
Yeah.
Okay, moving on to the last question, which is also very interesting as well. Actually, right, I want you guys to attempt this last question here. Tell me what's your final answer for the speed here. Guys, everyone start attempting this question here and tell me what's your speed. PM me on Zoom so I can see how many of you guys actually understand or don't understand. Okay, let's see the rest of the answers. Guys, I'll give you like 3 minutes to do this. Don't waste too much time, and after I want to move on to the next chapter really.
Sure, I cannot access the private message function in the.
Really? WhatsApp me then.
Okay.
Which chapter are you in school right now?
Kinetic. Not kinetic. Energy basically.
Oh, you guys are at energy
Learning
already.
the advantages and disadvantages.
Okay, we're gonna do energy today as well. Okay, good. You have the same answer as Hayden. Now let's wait for Jolie. Mana answers are here. Okay, Jolie, time's up. What's my answer?
Wait, I just got my calculator.
Just got your. For the rest of you guys who already got your answer, you can flip to the energy chapter already. We're gonna do that. Zero point 0.5? Wrong. It's 0.2. See, now do. It's not about this is how you're supposed to do it. First and foremost, you most likely find that the momentum here is 0.16, right? Do you at least get this, Jolie? This one you got right. So 0.16 kg meters per second, by the way. Then after that, from here, you're supposed to use the principle of conservation of momentum, which is total momentum before collision equals to total momentum after collision, which in this case here, since there's only two objects, is going to be m1u1 plus m2u2 equals to m1v1 plus m2v2 here. Then from here, your first object will be this engine lah, right? Which is going to be here 0.5 multiplied by 0.32. Initially, this thing is stationary, so 0 lor, plus 0, anything times 0 is going to be 0, right? Then after that, you need M1V1, right? But they already told you that, yeah, they already told you that the mass of the truck later is this. You're looking for the speed of the joint engine truck. Joint engine truck means to say, what type of collision will this be, Jolie? Elastic or inelastic collision?
Elastic.
No, it will be inelastic. They join together. If they join together, they'll be basically both moving at the same time. This is what we call inelastic collision. Elastic is like you elastically bounce off each other and then they'll move in two different speeds. You get what I mean? So from here, you're actually supposed to change the formula a bit, no longer V1 or V2. It will just be a common V, like I've mentioned last week. Then after that, I just plug my numbers in, or it'll be 0.5 multiplied by V plus with 0.3 multiplied by V, which in this case here, you'll get 0.16 is equals to 0.8 V. Then after that, you press in your calculator, it'll be 1 over 5, which is 0.2. Okay, copy this down. Once you're done copying this down, flip to the next page. It's going to be the energy chapter already today. Hmm. Done. Done? Okay. Move on. Next. Where did Shane go? Oi. Okay, next we move on to the energy chapter here. There's going to be this is going to be quite calculation intensive, this chapter here, because we're going to do a lot of calculations. But we first need to do a little bit understanding on what type of energy will be tested in your syllabus, guys. Now, in terms of energy, I think this is nothing new. You've learned this since year 7, 8, 9 already, right? You know there are many forms of energy: kinetic, potential, chemical, sound, strain, nuclear, blah, 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 blah. But in your syllabus here, especially for this specific chapter, there are only 3 main energies that you will be asked to do calculations. The first one will be basically work done. The second one will be gravitational potential energy, and the third one will be kinetic energy. From all these energies here, you need to have a rough idea on what these energies represent. Then you'll be able to do this chapter quite well. Okay. First and foremost, if you think about work done, right? Work done is essentially how much force you move something over a specific distance. For example, if let's say there is a box here, right? And I push this with a force of 100 newtons. Okay. This box then after that moves a distance of 10 meters. Then the work done formula will be very straightforward, right? It will be basically force multiplied by my distance, which in this case here will be 1000 joules. Meaning to say, right, in order for me to move this box by 10 meters using 100 newtons, I'll need to output 1000 joules to move it. Guys, I've got a quick question. If let's say, right, my box is pushed against the wall already, and then I'm applying, like, let's say, 10,000 Newton 10,000 Newton worth of force onto this box. Okay. And obviously I'm sweating like crazy already. Is there any work done in this scenario? Is there any work done if I push a box that is already against the wall, but I'm sweating like crazy already? Hayden, what do you think? Yes or no? Yes. The answer is no. The answer is no. Why? While there is a lot of force exerted, there is no distance traveled. And because there is no distance traveled, we can't say there's any work done. You just apply a lot of force to the object, but there is no work done to the object. Understand? So in order for work to be done, the object must move a distance and you must apply a certain amount of force. Know what I'm saying? Huh? Okay, so that is work done. Then for gravitational potential energy, gravitational potential energy is basically energy due to your due to your position. In a sense that, let's imagine today, right? I'm standing on the ground versus standing on top of the table or something on top of something that's relatively tall. If both of you guys fall to the ground, which one hurts more and why? Junju, why?
The one standing on top, because
Good,
got height,
good. Why does it hurt more?
because more gravitational potential energy.
Good. Basically, let's just say if we talk about in terms of gravitational potential energy, this guy maybe have 10 joules, whereas this guy has, let's say, 100 joules. When you fall onto the ground, right, the energy dissipates, right? So basically, you're changing more energy over a short period amount of time. And this is the reason why you will definitely hurt more. And if you go even taller, maybe you'll break a leg or two, right? So the reason why it hurts more is because you're releasing more energy or you have a much higher position, so you'll have a much higher gravitational potential energy. Okay? And finally, the last one here is basically going to be kinetic energy. Kinetic energy is energy due to your motion. For example, if you were to walk into a wall at maybe 1 meters per second versus running into a wall at 100 meters per second, right? Once again, there's a greater dissipation of energy due to your faster motion, and thus it will hurt much more. Okay, before I proceed on, anyone don't get the idea or not? Basically, you just need to know that work done depends on force and distance. Gravitational potential energy depends on the height that you're on, and kinetic energy depends on the velocity that you're running at. Okay, everybody? Anyone has any questions from this part here?
Work done for displacement, right? Must be in meters the unit.
Yeah, must be in meters. If not, you won't get joules.
Okay.
Good question. Okay, so if you have no questions here, let's just talk a little bit about all this energy. So, hey, everyone, pay attention now, wait. Pay attention now, wait. Wait, Jolie, pay attention, wait. Look here, wait. Right? You see, all this energy, more or less, you need to know what they represent. Kinetic energy, we said already, is energy due to your motion. Potential energy is due to your position. Right? Chemical energy is due to what? Can you give me an example of something that possesses chemical energy, not Jolie?
A fan.
Sorry?
A fan.
No, a fan doesn't have chemical energy. A fan will have kinetic energy due to its moving blades, though. What about Hayden? Can you give me an example of something that has chemical energy?
I'm not sure.
Shane, anyway. Shane,
Let me back in my laptop. Wait. What was the question again?
what thing possesses chemical energy?
Battery.
Good. Batteries contain chemical energy, right? Basically, lithium cells that does the chemical reaction is the one that gives us that converts lithium cells are the one that converts chemical energy into electrical energy that we can use in our electronical devices, your phone, your your basically everything, a remote control, anything that uses a damn battery, right? It's all going to have chemical energy. In fact, very commonly, humans and living beings contain chemical energy as well. When we eat, our body converts that energy to chemical energy, which powers us throughout the day. You'll be asked on this in your exam. Sound energy, very straightforward. Anything that has sound is going to have sound energy, right? Strain energy, Jolie, your turn again. What's an example of something that has strain energy?
Uh, my hand.
Your hand? Interesting answer, but no. And you guys think about it, whenever we talk about strain energy, strain is very similar to elasticity, lah, right? Elastic stuff, lah, right? Anything that can be compressed or elongated when they bounce back to original position is because they have strain energy. For example, a spring, if I compress it, right, I'm basically storing strain energy there. And when I let go, the strain energy will actually bounce it back into position, right? Strain energy and elastic energy, is it elastic energy? Can't remember the name already. But these two are basically the same. Let's assume it's elastic energy first, until we see the question otherwise. Okay, elastic energy and strain energy, they're both the same thing. As long as you compress it or you can elongate it, once you let go, it'll bounce back to original position. Those are the things that have strain energy. Okay. Nuclear energy is basically how the nuclear power plants generate electricity in Japan, right? And this one is very important. It comes out very often on. Any idea what internal energy is, Hayden? Wait, Hayden.
Like our organs.
Organs are, okay, acceptable, but I don't think you might think about it in terms of the right context. Guys, write this down. Internal energy is anything that has heat. Right? A hot cup of water is going to have heat. In your case, okay lah, our organs are relatively warm, right? So it will have some form of internal energy, but it's got nothing to do with organs. Right? I think you lucked out on that one. Guys, whenever you see the word internal energy, it has to do with heat. Anything that has heat will have internal energy, and ultimately electrical energy is basically just anything that's running on electricity. Okay, guys. Anyone has any questions for this part here? No? Good. Copy everything down. Copy the formulas down and attempt the 6 questions. You have 10 minutes to attempt everything.
Rachel, I just consider potential energy as gravitational potential energy.
Yeah. In fact, right, in some mark schemes, they actually don't accept potential energy. You have to write the full gravitational potential energy. So
Okay.
just to be safe, write the full name at all times.
Will they ask like elastic potential energy?
They will, but it's actually the same as elastic energy.
Okay.
Good question. Hello everyone, are you done, my friends? Anyone not done yet? Oh, good. I think question 1, 2, 3, 5, and 6 is fairly straightforward. You could literally get the answer almost just looking at it. This one here will be basically 1,500 joules. This one here will be basically 40 meters. This one here will just applying the formula, right? And then you use your calculator. I don't think you'll be wrong. Question 4, however, is a fairly interesting question. Oh, shit. Question 4, however, is a fairly interesting question, though. My friends, who here did question number 4? Jolie, what is your answer for question number 4?
15 million joule.
15 million, wrong. Yeah, wrong. Hayden, what's your answer?
2.25 times 10 power 9.
I think wrong also. Shane, what's your answer?
Yeah. You want three significant figure?
Yeah,
Oh my god. 208 0000.
208 wrong, I think.
You
First
think?
and foremost, anyone converted this? Hey, guys, listen up, You know, in terms of these three formulas, right? The units for mass must be in kg, and the units for velocity must be in meters per second. The units for gravity must be in meters per second square. The units for height must be in meters. This must be in newtons, and this must be in meters also. If not, you will not get a derived unit of joules. What do I mean by derived units? Derived units are basically like this thing times this thing plus this thing becomes that something. Okay. Simple units are basically like kg, right? This is like mass is kg, lor, right? Another simple unit is speed, lor, meters per second, lor. But joules is usually a derived unit, because it must be a combination of few things combining together, right? So first and foremost, who here converted this into the proper units? Did anyone even attempt to convert? Or do you guys straight away just 300 square?
I converted
Oh, how much is your conversion?
83.33333.
Oh, okay, good. You are actually supposed to convert it. So first and foremost, everyone just pay attention to this question here, right? Okay, you're supposed to know that it's 300 km per hour. You want the final answer in meters per second. So the first thing is you convert this thing on top, right? 300 km is how many meters? You'll realize that it's actually 300,000 meters, right? 1 hour is how many seconds? You'll realize that it's somewhere around 3,600 seconds, right? Then you press your calculator, this thing divide by this thing, which you'll get, how much 83, 0.333. Is it?
Yes.
83.3 meters per second. With this 83 meters per second, you're supposed to use the kinetic energy formula, which is half mv squared. It's going to be half multiplied by 50,000 multiplied by 83.3 squared. And then you get an answer. But I don't have my calculator. So what's the answer?
173,472,250. So it's 173,000,000.
Standard form, bro. 1.73 times 10 to the power of
6.
6 joules.
Wait, not 6.
Is it 6 or 8 or 7?
8.
8. Can someone else double confirm this? I don't have my calculator with me, but if you press everything in,
It's correct.
yeah, you should get the proper answer. Okay, guys, remember if you have an extremely big number, don't write a lot of zeros or numbers in. You have to put it in standard form. Okay? Gentlemen. And finally, yeah, this one all also very straightforward lah. Just go MGH, right? It's basically going to be 50 multiplied by 9.8 multiplied by 300. And this one is basically going to be MGH also, which is 5 multiplied by 9.8 multiplied by 10. There you get your answers. Very straightforward lah. Press in your calculator lah. Only one I wanted to highlight was question 4. Okay, anyone has any questions with regards to these 6 questions? Good. Shane, class ends at 7:45 though. So wait, your other tuition 8 p.m. is a physical class ah?
No, it's like online, but I have to eat dinner and like I have to rest a bit.
Can't you eat dinner earlier before 6:30?
It's kind of early, man.
Okay. Then you're gonna miss out on some of the things at the
Can
end.
you teach faster a bit?
Faster a bit There's still so much to cover, bro.
Okay, teach now.
Okay, anyways, the next thing I want to talk about is basically the principle of conservation of energy. Last week we talked about principle of conservation of momentum, right? Right now we're going to talk about principle of conservation of energy here. Okay? In your syllabus, I noticed that they love to ask, okay, first and foremost, even before talking about your syllabus, right? You need to know that principle of conservation of energy states that total energy can never be created nor destroyed, always transferred from one form to another. Okay, you've definitely seen this statement in year 9 before. It's in your textbook one, right? If you were paying attention. But anyways, since energy is always conserved from one form to another, in your syllabus in IGCSE, they love to convert potential energy into kinetic energy or vice versa, kinetic energy back to potential energy. An example of potential energy to kinetic energy is, imagine today you're unhappy and you decide to climb KLCC for one last ride. You'll be at the highest peak of your life, or are you at the lowest point of your life since you're deciding to, I don't know. Anyways, so this is basically an example of potential energy to kinetic energy, right? Because initially you have damn a lot of potential energy, and then later 0.00001 second before you go and meet your maker, right? You'll have the maximum kinetic energy here, right? Right. So this is how we convert potential energy to kinetic. This is one example. Another example is basically like, let's say I'm throwing a ball, right? This ball initially is already moving. Let's say it's at 10 meters per second. And it's gonna be thrown upwards to a certain height, right? Let's say it's a certain height. I don't know how much is that height. This is an example of kinetic energy into potential energy, right? You need to identify these two scenarios here, potential energy to kinetic energy or kinetic energy to potential energy. In these two scenarios, it's very straightforward. You have to understand that it's basically going to be, since potential energy is converted to kinetic energy or vice versa, right? The formula here is basically going to be mgh equals to half mv squared. Okay? Now, here is the question I want to ask everyone. If let's say today in your exam, right, they could give you 2 ways. They could tell you that, okay, this thing is 50 kg and he's initially standing at a height of, let's just say 70 meters. Calculate how fast is he falling here. Can calculate or not? How to calculate? Can I know how to calculate it? Okay, the first way to do it is actually understanding that the formula is as given already, right? You literally just need to substitute your information into the formula and you'll be able to find your velocity. In this case here, it will be literally 50 multiplied by 9.8 multiplied by 70 equals to half. The mass doesn't change, right? Even though you're falling to your maker already, right? You're still not going to change mass, right? You'll still be 50 kg, and from here, one unknown in the one equation. You can do algebra and find it out, right? Right, yes, everyone. You know what I'm talking about or not? Can I get some response, at least some head nodding? Huh? Right. So if let's say in your question, right, which this is what IG and CSE love to do, they'll tell you that they won't give you the mass this time. They'll just tell you that this height here is, let's just say, 30 meters. How to find the velocity? Can find? Can find in this scenario?
Just the height alone.
Just the height only. Then they ask you to find the velocity. Can? We can.
Cannot.
Can. Answer is can. Why can? Because if you think about it mathematically, right, is mgh equals to half mv square, right? There's two masses on this side here. It doesn't matter how much the mass is, actually they'll cancel off each other, right? You know what I'm talking about or not? Right? Mathematically, there's two m's on both sides. I don't care lah. This guy could be 100 kg, 1,000 kg, or 1,000,000 kg lah. I don't care. In the end, they're going to cancel off each other, right? That means to say, in reality, right, in order for me to find the velocity, all I need to know is how much is the height. How much is the height? Because the gravity is given already, what? 9.8 multiplied by 30 is equals to half v squared already. Then once again, you do your algebra, and you'll be able to find your answer already. You understand what I'm talking about? This is important. It always comes out in your exam, and a lot of students, they ask me, teacher, how to do? I don't have the math, haha. Shut up, lah. I told you this 1,000 times already at this point. That will be when they are attempting to pass your papers already, right? You don't need the mass because mathematically there will be two masses already on each side and they'll literally cancel each other off. Yeah. But I want to ask you, in reality, right, can 100% of potential energy be converted into 100% kinetic energy? Why not?
Air resistance.
Good, because there's a thing known as air resistance, right? And because there's air resistance here, maybe you won't get 100%. Maybe lah, maximum you'll get 90% only. And the other 10% is converted into heat or sound lah, right? Imagine if you run fast enough, you can hear the boom, 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 boom sound, right? This is that scenario already. So in order for this to be true, sometimes the question, they'll say something like, ignore air resistance. As soon as you see the word ignore air resistance, right, you can safely assume that 100% of the potential energy is converted into 100% of the kinetic energy. You know what I'm saying? Okay, guys, anyone has any questions about here? No question, Okay. No question, find out how high this thing is, given that this ball is flying up with an initial velocity of 10 meters per second, assuming air resistance is neglected. Aaron, give me this answer.
Sure, I leave the call. I send you the answer.
Okay, see you.
Bye.
Jolie, 14 is wrong, huh? How do you get 14? What's your calculation?
Fifty times 9.8 times 10 times 2 divided by 50 and then square root it.
50? But you don't have the mass here, so how do you use 50?
I know you put 50 there.
No, 50 is this question. I'm looking at this question right now, right? This ball is gaining height. How high will this ball get?
Oh,
It's the only information you have right now is that this ball is initially moving at 10 meters per second. Assuming air resistance is neglected, how high will this ball reach? Try to do the calculation again using this formula here. Hayden, 50 meters is wrong also. How do you get that calculation? What's your working? Okay, Hayden, what's your working?
MGH is 9.8 and 30, right?
30? 9.8 and 30? How come
Wait,
30?
no,
30?
wrong,
30 is
wrong,
this
no,
question,
wrong.
bro. Look
Yeah,
at.
yeah.
Okay, let me draw the picture again since everyone is getting confused. This ball is initially moving at 10 meters per second. I want to find out how high this thing is, assuming that half mv squared equals to mgh. Yeah, that's a closer answer. But not exact also. Well, good. It's supposed to be 5.1 meters because you're supposed to substitute that the mass is going to cut off each other. Then you just 10 square this equals to 9.8 h. Ngamo, everybody. Huh? Good. With that being said, this will be the last part of the day. Yeah, this will be the last part for the day. Today, there will be no homework. Unless, actually, this will be your homework, guys. This will be your homework for the day. Can you guys finish up these two parts? I think we'll end class here early today since both of them are missing. These two parts will be your homework. Finish it up. We'll discuss answers next week. And then after that, we're going to continue class with this last two parts here. Last three, 4 parts here. Okay, gentlemen, you guys got any questions you guys want to ask? By the way, I want to emphasize this is position 1, this is position 2, and this is position 3 for this calculation here. Because they'll talk about position 1, position 2, and position 3. I emphasize again, this is position 1, this is position 2, this is position 3. Okay? Okay, good. Please attempt these last 2 questions here. We'll discuss the answers next week. Before I go, anyone got any questions you want to ask? Good, as expected. Enjoy the rest of your night, gentlemen. I'll see you all next week.
Okay, bye.
Bye.